My name is Mitchell Bauer, and I'm a research engineer and team leader at Cornerstone Research Group. My background is in underwater systems, propulsion systems, and software development. The Navy asked us to improve mission performance for unmanned underwater vehicle platforms, and we've developed power and propulsion upgrades for these systems so that we can enable longer range, longer duration, quieter systems, and increased hotel load so that these platforms can use more powerful payload sensors. What we've developed is both a software and hardware solution. CRG is an aerospace and defense company located in Dayton, Ohio, where we've been operating for 25 years. Our goal is to take technologies from the early research and development stage and develop those technologies to the point where they are their own products, can be spun off into individual businesses or business units within CRG. We want to take those products that provide value and provide benefits and get them into the hands of the warfighter. We don't want to be developing technology that is going to sit on shelf. We want to develop products that will add value to the warfighters and to their missions. We have successfully launched multiple subsidiaries focused on propulsion systems, power systems, composite parts, civil infrastructure, and electric propulsion, and we want to continue doing that with the technology we're developing here. If you would like more information about CRG, our subsidiaries, or our products, feel free to contact me. The challenges we're addressing here are mission limitations of UUV platforms, such as not having enough power available to run the sensors that we want to run on these systems, not being able to run the UUV for a long enough range or a long enough duration, or UUVs that are not quiet enough to perform the missions that we want to perform with them. A lot of these limitations come from the limitations of the power and propulsion subsystems on board these UUVs. What we're addressing are those limitations of the power and propulsion subsystems specifically so that we can enable these UUVs to perform more demanding missions. The needs that we're addressing here include increasing hotel load. So for example, we can use more power for a more powerful sonar sensor that can see further through the water, or we could run multiple sonar sensors that can see in multiple directions in the water. We could also increase range or endurance so that these UUVs can be operating and performing their missions for longer in the water and spend less time on ship or on shore being refitted for their next mission. We're addressing these needs by designing and optimizing better power and propulsion systems that are more efficient so that the power that would have been provided to these power and propulsion systems is instead used either to run the UUV for longer missions, or that power can be provided to better payload sensors that better enable the UUV to perform more demanding missions. UUVs are becoming increasingly a larger part of the fleet, driving the need for this solution to improve UUV performance. To address these UUV mission limitations, we're providing both software and hardware solutions to enable these improved power and propulsion subsystems. The software we've developed analyzes UUV performance and identifies optimized power and propulsion components that could be used to enable more demanding missions for these UUVs. Once we've identified these components that can be used to improve performance, we then build the hardware for these power and propulsion subsystems that can be integrated into the UUV to enable longer, more demanding missions. This technology is based on previous work with unmanned aerial vehicles and is applicable to unmanned surface vehicles as well. This program is currently a Phase 2 STTR. Our objectives for this current phase are to, 1, validate that the performance predictions we're producing from our software of UUV performance are accurate. So we want to take experimental measurements and verify that those software predictions match those experimental measurements. And then 2, we want to demonstrate that we can improve performance over a baseline UUV system by integrating our optimized power and propulsion subsystems. We have successfully achieved all of those objectives in this phase. So we designed and optimized a propulsion subsystem, fabricated that system, and integrated it into a UUV platform. We took experimental measurements of both the baseline UUV as well as the optimized UUV that we developed. Our thrust and power measurements were matching closely with the thrust and power predicted by the software for both the baseline and optimized UUV, showing that our software was producing accurate predictions. We also compared baseline and optimized UUV performance and showed a significant benefit in power draw. The optimized UUV with our propulsion system demonstrated a 25% reduction in power consumption when compared to the baseline UUV. So our technology enabled the system to use 25% less power, which can then be reallocated to more powerful payload sensors or to extend the mission. Our current technology readiness level is at 4, and we can be at a TRL of 5 to 6 within a year of further development and testing. Some of the key benefits of this technology that we've developed here are improvements to UUV mission performance, such as increasing the hotel load, increasing range or duration, or producing quieter UUV platforms. We can also, with the software we've developed, look at some of the trade-offs between some of those performance benefits. So you could, with lower power used for your propulsion system, you could use more power for your payload sensors, or you could send your UUV out for longer missions. You could also do some combination of those things, slightly increase range, slightly increase your hotel load, and our software would enable you to visualize the trade-offs between those different objectives there. With the software, you can also analyze capabilities of UUV platforms that are either existing, already developed systems or systems that are in development. We can do that with both friendly and adversary systems, and we can predict what are the capabilities of those different UUV platforms. The software that we've developed is pretty low profile. It can run on a laptop computer and perform some of these analyses on the order of minutes. The upgraded power and propulsion components that we've developed here could be transitioned to the fleet in a couple of different ways. We could retrofit these components to existing UUVs, swap out current power and propulsion hardware, and plug in these new upgraded components to enable quieter platforms, to increase range or duration, or to increase the amount of power available. We can also integrate these power and propulsion upgrades with UUVs that are currently in development. So if there is a UUV being developed for a new mission and there is a need for a propulsion component there, we can develop an efficient quiet propulsion system for that and integrate that propulsion subsystem with the UUV platform as it's in the development stage. We're currently looking for customers or partners who are in need of upgraded power and propulsion systems or are in need of upgraded mission performance for UUVs, and we'd be happy to talk further about integrating these components into those platforms. We'd like to speak with unmanned platform OEMs as well as unmanned programs of record. The primary market that we're focused on for this technology is the defense market. The benefits that this technology provides, such as quieter platforms and increased power available for sensors on board these UUVs, is going to provide value for defense markets. The hardware components are primary technology deriving from this effort that will provide value for these applications. On the commercial side, some of the potential applications for this technology, some of the industries that this could fit within include the oil and gas industry, environmental surveying, or maintenance and inspection industries. We can get this hardware into customers' hands in a couple of different ways. We can transition the hardware directly to end users if they have UUV platforms that they're currently using that they would like to perform better. So we can take our power and propulsion components and deliver those to the end user for integration, swapping out the old power and propulsion components and integrating our better, higher performing subsystems. Another area that makes sense for integrating these power and propulsion components is with the prime contractors that are building these UUV platforms. So we can support those primes by providing our components as a subsystem to their overall UUV platform. either for UUVs that they've previously developed and that are currently being deployed, or we can integrate these components earlier in the design stage as they're developing new UUV platforms. We're looking to talk more with these potential customers and partners to figure out how we can get this upgraded hardware into their hands. Thank you, everybody, for your time and for attending this Tech Talk. I'm happy to sit down with anybody who has further questions or interest in this technology or any other technologies in CRG's portfolio. Once again, my name is Mitchell Bauer with Cornerstone Research Group. Feel free to email me or give me a call, and I'm happy to discuss the power and propulsion upgrades we've built for UUV systems in more detail. Thanks.